Hi, everybody. We've been looking at sports science recently, and the first video we did an introduction to sports science and its impact on athletics and paddling in particular. And in the second video, we looked at the energy systems. In a quick review, we looked at the aerobic energy system, which produces lots of ATP, which is the energy currency in the human body. Remember that ATP is a molecule called adenosine triphosphate. It has 3 phosphate bonds, and when one of those phosphate bonds is broken, it releases a tremendous amount of energy that can be used to make the muscle fibers contract. And so the aerobic system it must occur in the presence of oxygen. It requires oxygen to produce ATP. It produces relatively large amounts of ATP, and as long as there's oxygen being delivered to that system, it can go on pretty much indefinitely. In contrast to the anaerobic systems, which do not require oxygen, they produce smaller amounts of ATP. There's 2 systems. One is called the anaerobic alactic system, and it burns a fuel called creatine phosphate to produce ATP. It produces quite small amounts of ATP, and it only lasts for about 10 to 15 seconds. So you might use that in the initial sprint at the start of your race, or if you're a 100-meter sprinter on the track, you'll use it for your entire race. Once it's used up, it requires a period of rest for that creatine phosphate to regenerate. And so it's not like it can go on indefinitely. Once the creatine phosphate is used up, you need to rest, have it restored, and then you can use it again. So it really is only like a one-time thing in a paddling race. The system that we would rely on more when we're working anaerobically is the anaerobic lactic system. They call it lactic because it's producing lactic acid. You've probably heard about lactic acid. It's a limiting factor to human performance because as it accumulates in the muscle fiber and in the bloodstream, it reaches a point where it basically prevents the muscles from contracting properly. So when lactate gets up for some individuals around 8 millimoles, for others up to 12, 14, 16, 18 millimoles, like that's a really high amount of lactate, it leads to the inability to continue doing exercise, doing movement. Your muscles start to fail to contract. And so lactic acid is something that needs to be managed so that we don't produce too much of it when we're performing. Ideally, you want to work aerobically because you could work indefinitely with that. The problem is when you reach a point where you can no longer deliver enough oxygen to the working muscles, if you want to keep going hard and faster or harder than your body's ability to get oxygen to those working muscles, you need to supplement what the aerobic system is doing with anaerobically produced ATP so that you can keep working at that high level. And that's where the anaerobic system comes in. What I'd like to do today is I'd like to talk about the aerobic system. And in particular, I'd like to talk about something called VO2 Max. A lot of people who do sports have heard of the term VO2 Max. I'm not sure the degree to which people understand it. So let's talk about it. VO2 Max is simply the maximum amount of oxygen that your body can process, can get to the working muscles and use to produce ATP. And it's can be measured in 2 different ways. In absolute terms, it's usually measured in liters. And so it's, your VO2 max might be 3.5 liters, or in a big individual, a tall individual with big lungs, it might be 5 liters or 5.5 liters. More frequently, we see it expressed in relative terms, relative against body weight. So you'll see it expressed in milliliters per minute per kilogram of body weight. And you're going to see numbers that range anywhere from the 20s in a relatively unfit person to up into the 80s for an extremely fit world-class athlete. When I last had my VO2 max tested on a treadmill, it was 78 milliliters per minute per kilogram. And when I had it done in a canoe, as part of the same study, it was only about 48. And you might be wondering, well, why was it so high in the treadmill and so low in the canoe? And it comes down to the fact that when I'm paddling in a racing canoe, I'm kneeling on one knee. My legs are relatively immobile. I mean, they move back and forth a little bit. I use my hips to generate power in the pull, but you don't use your legs to the degree that you do when you're running on a treadmill. Or another popular way to measure VO2 max is to have the test subject riding on a spin bike. The more muscle mass that's engaged, the more oxygen you're going to be using. And the higher your VO2 max is going to be. Usually when you're tested, you're hooked up to what they call a metabolic cart, which basically has you wear a mask and it allows you to inhale air, breathe it, get it to your lungs where gas exchange takes place. Oxygen is then carried in your bloodstream to the working muscle, and carbon dioxide is carried from the working muscle to your lungs and then is expired, right? And so the unit that you're connected to by a hose measures the amount of carbon dioxide that's been expired, and it can calculate the amount of oxygen that you consumed, used, and the amount of the volume of carbon dioxide that you expire. More recently, the technology has arrived that you can actually do like portable testing where you don't have to be hooked up to the metabolic cart, where you can actually have a mask unit on, but it allows you to go and exercise away from the metabolic cart and not be attached to this stack of analyzers and computers beside the treadmill. And this is extremely valuable because it allows you to actually do on-water testing for a paddle sport, for example. So we could put somebody on a paddleboard and test their VO2 max to see what it is in a paddleboard. Interestingly enough, paddleboard VO2 maxes are higher than racing canoe VO2 maxes. And you might be wondering, well, why is that? They're both paddling, but you're standing up and you're using your legs more in a paddleboard than you do in a racing canoe. So it makes sense that your VO2 max is likely going to be a little bit higher, probably in the 50s for a really fit athlete. Still not as high as it would be if you were tested on a treadmill. So the question is, well, what's the meaning of this VO2 max? What's the importance of it? And how can that be used as an indicator of performance in a largely aerobic sport like paddling? Well, the higher your VO2 max is, the more capacity you have to utilize oxygen to produce ATP, the better you're going to be at producing ATP aerobically, right? The better you're going to be able to perform aerobically. And that's important because remember, when you can no longer perform aerobically, you start to supplement your aerobic system with anaerobically produced energy. And that is when the clock starts ticking, because if you use it for too long, you build up too much lactic acid and you're going to be forced to stop. So it's a big advantage if paddler A can work at a particular speed, say at 6 minutes per kilometer pace, working 95% aerobically, compared to paddler B, who is not able to work at that aerobic level. They're maybe only working 70% aerobically, and the other 30% to allow them to go that speed is the ATP is being produced anaerobically. And that paddler is going to tire out or be forced to stop more quickly because ultimately they'll be producing a lot of lactic acid. And so VO2 max, being a measure of one's aerobic capacity, right? The amount of oxygen that you can take in and use to produce ATP is a really good indicator of aerobic performance. And so you will see athletes in aerobic sports in particular testing their VO2 max to sort of see what level they're at. And a test that's taken only once really doesn't tell you much. It might tell you what your VO2 max is, but it really doesn't mean anything unless you test repeatedly and you can compare ongoing tests with your baseline figure, because that will show you the direction your fitness is moving in. And when we train, the whole idea is that we're trying to improve our fitness, right? So, you might do a VO2 max test at the beginning of the paddling season, or even at the beginning of the off season, because the off season is a great time to work on your aerobic capacity. So say you did it at the beginning of the off season. and you did it on a treadmill, and your VO2 max was 57, just for example. And you did a lot of really high quality aerobic training through the winter, it's likely that that VO2 max might increase up to maybe into the 60s by the end of the winter. And then when you're on the water, you want to try to make sure that you're improving your aerobic capacity as well in a specific sense while you're doing your paddle sport. And hopefully your VO2 max could increase through the paddling season as well. The important thing is that you need to do a certain type of training, ideally, to really see your VO2 max improve. Remember, VO2 max is the maximal amount of oxygen that your body can utilize to produce ATP. So if we're trying to really test our aerobic capacity, we need to be training at a fairly high level. So the workouts that are really good for working on VO2 max are aerobic, we call them aerobic power workouts, where you're doing like really high intensity kind of high end level 4, even level 5 repeats of anywhere from 2 to 4 minutes long, with not equal rest, but high level rest. So you might have, say you're doing one of the workouts I like to do for aerobic power is say 2 times 4 minutes, 3 times 3 minutes, 4 times 2 minutes, all with 2-minute rest. And so the athlete's working really hard in each of those pieces, and heart rate is close to maximal. It's not maximal, but VO2 max heart rate is actually usually within a few beats of your actual max heart rate. So you're working really hard, and this is the type of work that over time can help you push your VO2 max to a higher level. At the same time, you can't do that work all the time. It's extremely demanding, especially on your nervous system. And so you might do that type of work, once a week in the early season, and in the when your program really intensifies in the racing season, you might be doing that type of work, 2 to 3 times a week. And the other workouts that you're doing are going to be more base level, because you do improve your aerobic capacity as well, working at level 2. But a lot of the changes, adaptations that improve your aerobic performance at that level are happening at the cellular level, like increasing the amount of mitochondria in your muscle fiber, increasing the ability to move oxygen from the cell membrane to the mitochondria, increasing the activity of enzymes that are involved in aerobic metabolism. So you're not necessarily improving your aerobic ability by improving your VO2 max when you're doing that type of training, but as your aerobic ability improves through that type of training, it's likely to nudge your VO2 max a little bit higher as well. Why would you want to get your VO2 max tested? Again, it gives you an example of where you're at in terms of your aerobic fitness. That should be a predictor of, to a certain degree, of your performance in a very aerobic sport like paddling. And then if you are able to test on an ongoing basis, it helps inform you, about the effectiveness of your training. Like, you should see improvement if your training is effective. If you're not seeing improvement, it gives you reason to, explore what you're doing in your training and should you be doing something differently. It allows you to, you can set some fitness goals that you think might make a difference might help you achieve your performance goals. So if you are able to, increase your VO2 max by 3 or 4 milliliters per minute per kilogram over the course of 3 to 6 months, that might result in a noticeable improvement in your performance in an aerobic event. That's VO2 max in a nutshell. There are lots of devices like Garmin's and things like that that will predict your VO2 max, or as you're working, it will suggest to you what your VO2 max is while you're doing it. Bear in mind that these are estimations, and there's also lots of VO2 max calculators that you can find on the internet where you can, they have you do a certain distance at a certain speed, or if you can do a certain distance at a certain speed, it will predict what your VO2 max is. And those are useful because they get you into a ballpark area for what your VO2 max is, but they're not the same as actually testing. And so if you're really interested in what your VO2 max is and you're really interested in improving your aerobic performance, ultimately that means improving your speed, right, over a given distance in a race. The best approach is to actually get it tested properly. And so that's VO2 max. I'll leave it at that for today. If you've got any questions, please reach out and ask, and I'll try to answer them for you. Next week, I'd like to look at another interesting marker that we can test, and that is the anaerobic threshold. We can determine the anaerobic threshold, which is the point where you no longer are able to work solely aerobically and have to start to augment your aerobic work or your aerobic production of ATP with ATP that's produced anaerobically. And so that's the point, that's the threshold of your aerobic ability and where you start to go anaerobic. So they call it the anaerobic threshold. And clearly that has implications to performance as well. I'm sure you can guess at what those implications are from the introduction I gave to this video, but we'll talk about that in greater detail in the next video. All right, happy training, and I'll see you again.